What the is spin? Spin is a quantity that we talk about in quantum mechanics a lot. Usually we'll talk about some particle like an electron or a photon that can be spin up or spin down. But is the electron actually spinning? No, the electron's not actually spinning itself. It's an intrinsic quantity for that particle. The particle wouldn't be the particle that it was without this quantity called spin. And the best way to understand spin is to look at the Stern-Gerlach experiment. So the Stern-Gerlach experiment was, you have this magnetic field, you shoot electrons through the magnetic field, and then you have a screen, a detector, where you can see where the electrons end up. According to regular old electromagnetism, what should happen? The magnetic field should deflect the electrons. There should be a grouping, a big band of electrons that builds up. But that's not what happens. There isn't a big band of electrons that builds up. There's two big bands of electrons that build up with a gap in the middle. Now, the gap in the middle isn't really the problem. Again, we assume that they shouldn't end up directly in the middle relative to the height of the beam, because they should get deflected by the magnetic field. But what they definitely shouldn't do is bunch up in two different bands. Why does that happen? It breaks all the existing theories at the time when the experiment was done in 1922. There's no uncertainty principle yet. The work hasn't been published by Heisenberg. So what's going on here? Well, electrons have this intrinsic quantity called spin. Now, the weird quantum mechanical part of this is that they can be different values. So you could have a spin up or a spin down electron, and you don't know if it's a spin up or spin down electron until it ends up on the screen. If it deflects in the upward direction, we say the electron was spin up or is spin up. If it's deflected in the downward direction, we say that electron is spin down.